Here we have another example with a polynomial. We're going to find the zeros, the x-intercepts, and factor the polynomial. So again, remembering the fundamental theorem of algebra, this is a degree 3 polynomial, so I know that I have 3 zeros. Taking a look at the graph, I can see a 0 here and then possibly zeros here. So we're going to have to investigate that a little further. So what we want to do first is graph it and find any rational zeros that we can from the calculator. So from here we can see that I have a 0 at -4. From this second area, I'm getting a 0 at 0.50000002, so we might do a little bit of algebraic work to double check and make sure, is that exactly 0.5 or is it an irrational number? So I do know that the -4 is a net rational zero, so what I'm going to do then is use synthetic division with that -4 to see what we're left with and then work from there. So my 0 is the -4, so I'm going to use synthetic division again. If you prefer to use long division, that is fine. Doing synthetic division with a 0, your remainder should always be 0, and then you're left with your polynomial. So this gives me 4x squared minus 4x plus 1. And then I can factor this easily enough into 2x minus 1 and 2x minus 1. If you prefer, you can use the quadratic formula to solve that. So this gives me that I have a double root here at x equals 1/2. So that tells me that this on my calculator is exactly 1/2, but the calculator is just slightly off from its accuracy there. So now what I know, going back to what the question asked us about, A asked us to find the zeros and the x-intercepts. So my zeros are x equal -4 and 1/2. Both of those are real numbers, so those are both x-intercepts. So my x-intercepts are the point -40 and the point 1/2. And then part B asked me to write completely over the set of integer numbers. So we had 4x cubed plus 12x squared minus 15x plus 4. So using my zeros, I'm going to write x plus 4 and then x minus 1/2. And that's actually twice x minus 1/2 again because this was a double root. The question asked me to write this using only integers. So remember your leading coefficient here is a 4, so that should, in factored form, my leading coefficient should give me a 4. So remember, by moving the denominators here, that's going to get all of my values in my factored form to be integers and will also give me the appropriate leading coefficient. So I'm going to write this x plus 4, 2x minus 1, 2x minus 1. Or if we prefer, we could write this x plus 4 and then 2x minus 1 squared.